and welcome back to my Physics Online video lecture series. Today's video we're going to be talking about force and Newton's law, or Newton's force laws. I'm just wanting to give a basic topical introduction to this in today's video. We will of course dig a little more deeply into Newton's laws and forces and the applications of forces in future videos. So let's get into things, shall we? Maybe the first question that you might want to ask yourself in watching this video is, what is a force? So what is a force? Well, a simple way of describing a force is a push or pull. So this is like the question. The answer is it's a push or pull. So if something is pushing or pulling on something else, then a force is being applied. If you have an object and you push the object, you're applying a force to the object. If you pull the object, you're applying a force to the object. The Earth's gravity pulls the object towards the Earth. That's a force. The object is charged, and there's another charged object nearby which repels the object. It pushes it away. That's a force, etc. So that basically is what a force is. What does it do? Well, that's where Newton's laws basically come into play. What it does is basically what Newton's laws are describing. So Newton's force laws govern forces. Before we get into Newton's force laws, it's worth noting that there are kind of two ways for dividing forces. Two divisions of forces. Okay, the first way to divide forces is by how they operate, meaning are they contact or field? All right, a contact force, if I push on something, that's a contact force. If I grab something and pull it towards me, that's a contact force. If two objects are sliding across each other, causing friction, that's a contact force. Gravity, on the other hand, is not a contact force. You can have an object that is released from somewhere above the Earth's surface, and it's still pulled towards the ground. So gravity is not a contact force. It is a field force, as it turns out. The other way that we can do divisions is basically fundamental forces and essentially everything else. You might call these other forces like subordinate forces or some such thing. So fundamental forces, that we know of, kind of four. Okay, there are two that apply macroscopically. There's gravity, there's the electromagnetic force, there's the strong nuclear force. This is what binds atomic nuclei together. And then there's the weak nuclear force. Now, the argument might be made, especially in light of Einstein's relativity theory, that gravity is not so much a force as a distortion. That is sort of beyond the scope of our course. So for our purposes, gravity is a force. The electromagnetic force, electrostatic, magnetic, etc., coulombic, those are forces. Strong nuclear is a force, weak nuclear is a force. Oddly enough, all four of these also happen to be field forces. So in some sense, this contact or field force is just a different way of looking at this fundamental versus other forces. All right, so what about these Newton's laws, the things that actually govern forces? Sir Isaac Newton brought together and formulated a set of three laws. Now I have to say brought together because at least two of them were first formulated by other thinkers. Specifically, the first law is known to have been formulated by Jean Buridan a few hundred years before the time of Isaac Newton. And Newton's second law was first formulated by René Descartes, again, about 100 years before the time of Newton. 50 years before the time of Newton, maybe 100 years before Newton wrote them down as laws. So these were not all first formulated by Newton, although he did combine them all He did maybe add some mathematical exactitude to them that wasn't there in the original form, but they were first formulated prior to the time of Newton. The third law, as far as we know, was in fact Newton's original law. And the third law really ties the other two together, and the three of them do form a coherent whole. So even if we acknowledge that he didn't formulate the first or second law, it's still proper to call them Newton's laws, because as a set of laws, Newton is the one who formulated them and basically understood, or first understood, what they meant. So what are Newton's laws? What are these force laws that we want to know? Well, I'm just going to number them. They're basically Newton's first law, Newton's second law, Newton's third law. So number one, or if you prefer, first law, basically says that mathematically, if the sum of forces acting on an object is 0, then the object is in equilibrium, meaning that the acceleration of the object is 0. And this is object is in translational equilibrium. Now, in a future video, we will discuss the difference between translational and rotational equilibrium in the context of equilibria in general. But for our purposes right now, we might even just say object is in equilibrium. If it's a point object, certainly there's not much in the way of rotational equilibrium to be had. The second law basically governs what happens if you have a net force. So a net force, force net, sometimes all lowercase, sometimes written force total, is the same thing as the sum of all the forces acting upon an object. And this net force is the object's mass times its acceleration. So that's Newton's second law. Basically, it's telling us now what happens if the system is not in equilibrium. So we have systems in equilibrium, systems not in equilibrium, we expect an acceleration. Later on, we will discover that this is actually a simplification, that the quantity is not ma, but rather a rate change of a quantity called momentum. But for our purposes right now, things don't change their mass, and therefore F net is ma. Newton's third law, which is the one that, as far as we know, was first formulated by Newton, kind of ties the other ones together, basically involves what happens when you have two objects. If you have two objects and they're interacting with each other, classically, that means that they are applying a force on each other. And the third law basically says if I have one object and it's applying a force on another object, then the other object will apply the same amount of force back on the first object, but it will do so in the opposite direction. These subscripts, by the way, should be read F12 and F21, not F12 and F21. They're F12 and F21. This is basically, you could think of this as the dynamics equation or the dynamics law. This right here is the statics law. And the last one is the action-reaction law. So these are basically what Newton's three laws are doing and describing. Now note that between them, they basically govern forces in general. There are other laws that govern specific types of force. For example, you have Hooke's law, which characterizes the force that a spring will apply when stretched or compressed away from equilibrium. You also have Newton's law of universal gravitation, which specifically governs gravity as a force. Okay, but this set of three laws goes with forces generally considered. Now, I'm not going to apply any examples. I'm not going to do any examples in today's video. I just wanted to give a brief overview and introduction to the topic, which I have now done. So, that's all for today, and thanks for watching.